In this unit, we are going to be studying redox reactions. Our essential questions are what happens during a redox reaction and how can a redox equation be balanced. By the end of this video, you should be able to identify a species, meaning an atom or an ion, being oxidized or reduced, and write the half reactions for oxidation and reduction. Redox is simply short for oxidation and reduction. And reduction is defined as the gaining of electrons. Now, reduction and gaining sound backwards. However, if you think about it, electrons have a negative charge. So if you gain electrons, your charge is going to go down. So when it's talking about reduction, that reduce is actually referring to the charge of the substance. So gaining electrons is defined as reduction. Losing electrons is oxidation. And one way that a lot of people use to remember that is LEO for losing electrons is oxidation, and GER, gaining electrons, is reduction. Here we have an example of a simple redox reaction. Sodium plus O2, O2 because it is a diatomic, forming Na2O. And this equation is not balanced right now, but that's okay. It doesn't need to be balanced for what we're doing. And in fact, we're going to be learning how to use what are called half reactions in order to balance an equation. So when we're looking at this, what we want to do is separate the oxidation process from the reduction process. So a half reaction is going to show half of the reaction. One of those elements is going to be oxidized, the other one is going to be reduced. And our half reaction is only going to show one atom of each element that we're discussing. And each half reaction will only be dealing with one element. So in order to determine what is being oxidized and what is being reduced, we need to know the charges in both the reactants and the products. The first thing to remember is that if you have an atom, by definition, atoms are neutral. So if there's no charge written and the element is by itself, it automatically has a charge of 0. So in this case, on the reactant side, sodium has a charge of 0 because it's off by itself. Oxygen, O2, even though there's two of them, it's still a pure element. So oxygen also has a charge of 0. On the product side, we have an ionic compound. Sodium and oxygen have combined. Now, remember, the metals will always form a positive charge. And if you look on your reference table, on your periodic table, it tells you that sodium will always form a +1 charge. And oxygen will always form a -2 charge. So we know that in this product, sodium is a +1, oxygen is a -2. Now, if we had something like iron over here, we would have to use what we know about the charge of oxygen to figure out what the charge of iron is in that compound, just like we did when we were naming it and finding that charge so we could give it the correct Roman numeral. So now we're going to look at what is happening to the charges. Sodium is going from a charge of 0 to a charge of +1. In order to do that, does the sodium have to gain or lose an electron? To go from 0 to +1, the sodium has to lose an electron, and losing electrons is oxidation. So we have sodium 0 turning into sodium +1, and that is going to be part of our half reaction. So for our half reaction, we take the sodium as it starts, arrow, the sodium as it ends up. But we also need to have a balance of charge. So the difference between oxygen and sodium is only 1 electron. So I know I need to write electron in the equation somewhere, but does it go on the reactant side or the product side? Here, the sodium is losing the electron, which means that electron is no longer part of the sodium. So that electron is going to go on the product side. Just like when we lost heat, we were producing heat, it was going on the product side. So we have Na0 forms Na plus 1 plus an electron. So this is showing the sodium atom is becoming a sodium plus 1 ion, and it's lost that electron. If we look at oxygen, oxygen is going from a 0 to a -2 charge. In order to become -2, does the oxygen need to gain or lose electrons? To go from 0 to -2, since electrons are negative, the oxygen has to gain electrons, which is reduction. So we're going to have O as it starts with a 0 charge, arrow O as it ends with a -2 charge. Again, we are only dealing with one atom of that element in our half reaction. In this case, the oxygen has to gain 2 electrons. So there are 2 electrons that were not part of the oxygen to begin with that are now. So that means my 2 electrons are going to go on the reactant side of my equation. And this shows an oxygen 0 atom gaining 2 electrons that were not originally part of it to form an O-2 ion. So when we're looking at a reaction, in order to write the half reactions, we need to know what the charges are in the reactant side and the product side. If the electrons are being gained, meaning the charge is going to go down because I'm gaining negative charges, it's going to be reduction. If the charge is going up, then I must have lost those negative electrons, which is the definition of oxidation. To write the half reactions, take one atom of the element as it starts, arrow one atom of the element as it ends up, figure out how many electrons different there are in the 2 species that you're dealing with, and if it's losing electrons, those electrons go on the product side. If it's gaining those electrons, the electrons go on the reactant side.